All right, and then I just want to give examples. So take a look at example 14. This would be in your notes. The first thing I would do on a problem like this is I would take out, I would take out at least a 2. Okay, I can take out a 2 and make this smaller. You do not have to, but I would suggest it. So that's going to be 2x to the 4th minus 7x squared plus 6 equals 0. So if I look at my chart, I have factors of 12 that add up to -7. My factors are -3 and a -4. Now I can't just plop those in the middle. That doesn't work this way because I have a 2 up front. So you could do this by grouping 2x to the 4th minus 3x squared minus 4x squared. So you're putting these numbers in the middle and then plus 6. And so then I can group. I would take out, I'm going to bring this down so it's there. I would take out an x squared, and that would leave me with a 2x squared minus 3. And here I could take out a -2, and that would leave me with a 2x squared minus 3. So my final factoring answer would be with the 2 up front, 2, and then that would be x squared minus 2 and 2x squared minus 3. So those are my factors. Now you can take each of these factors and you can set them equal to 0. So you'd have x squared minus 2 equals 0. So I'd have x squared equals 2, and then I would square root both sides. So this answer would be plus or minus the square root of 2. So 2 of my 4 roots would hit the axis. They would just hit the axis at kind of ugly decimals. And then I would do the same thing here. I would have 2x squared minus 3 equals 0 because neither one of those are difference of squares. I would add the 3 and then divide by 2 and then square root. Now we need to talk about this, and we've talked about it before, but I'm not going to accept a radical, so it's going to be plus or minus 3 over root 2. You have to think back to geometry. I'm not going to accept a radical in the bottom, so what I did is I took this radical and I separated it, and now I can multiply by root 2 over root 2, because on the bottom that would give me root 4, which is 2, and on the top it would give me plus or minus the square root of 6. We have talked about the fact that you can't have radicals in the bottom, so you would have to make that change to get 100% on this problem. Now think about kind of what we've talked about the last couple of days. A lot of your mistakes and things like that, it's just little things, and so you can't ever leave radicals in the bottom. Okay, so you just have to kind of take care of that. All right, example 15, and you can take a look at it, and then you can pause, and you can try it, or you can watch. I don't really care. So if you look at 15, this is a difference of cubes because 27 is a perfect cube. So you would have x minus 3, and then you would have had x squared plus 3x plus 9. So if I solve this one, my root would be 3. So there's one of them. If I look at this, I have factors of 9 that add up to 3. 1 and 9, that adds up to 10. 3 and 3 adds up to 6. I don't have factors. So I can complete the square, or I can do the quadratic formula. So I'm going to complete the square first. So I would minus the 9 to the other side. And I would half this, which is 3 halves, and I would square it, which is 9/4. And so then I would have x plus 3 halves, parentheses squared, equals, so this would be, let's see, -36/4 plus 9/4. So this would be a -27/4. Then I would square root both sides. And so I'd have x plus 3 halves equals plus or minus I root 27 over 2. And then I would minus this to the other side. And they both have 2's underneath. So I'm going to write them on 1. Plus or minus 27 can be split up as 9 times 3. And the square root of 9 is 3. So this would be 3I root 3 over 2. And so that would be my other 2 answers. This counts as 2 answers because I have a plus or a minus. So it counts as 2 answers. So there's root 1 as my 3, And then these two are my other two roots. Okay, example 16, perfect cubes. So this is going to be 2x plus 5, and then it's going to be 4x squared minus 10x plus 25. Okay, and so if I solve this one, that would be a negative 5 halves. If I do this one, I really don't want to complete the square because I said I don't care what you do. I'm going to do a negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So let's see, inside of here, that would be 100 times 4 is 400. So you'd have 100 minus 400. So that would be a negative 300. Okay, I could split this up by saying 100 times 3. And the square root of 100 is 10. So this is going to be plus or minus, and it's going to be 10i root 3 over 8. And then I can divide everything outside by 2. So 5 plus or minus 5i root 3 over 8. That would be your correct answer using the quadratic formula. And I would definitely let you have a calculator on this. If you're concerned about making sign errors, I've tested you over doing the quadratic formula without a calculator. So on something like this, I would let you have your calculator. All right, example 17, there's 3 terms, which means I would check your grouping. So factors of a negative 24 that add up to 10. Let's see, I would have 24 and a negative 1, that's 23. I would have 12 and a negative 2. Oh, there it is, right there, 12 and a negative 2. So I'm going to put that 12 and that negative 2 in for the middle, and I'm going to group. Some of you are still doing this stuff in your head. I'm totally fine with that. So I'd have 4x squared I can take out. That would leave me with a 2x squared plus 3. And here I can take out a negative 1 because if I can't take out something, I've got to at least take out a 1. So that's going to be 2x squared plus 3. So now I know this was going to work because I had a table. So this would be 4x squared minus 1 and 2x squared plus 3. This one is still factorable. 2x minus 1, 2x plus 1, and then 2x squared plus 3. And some of you are wondering, well, would she take off if we didn't do this last step? I'm going to tell you right now on the test, I'm going to kill 2 birds with 1 stone. I'm going to ask you factor completely and then state the roots instead of making a section where you factor and a section where you find the roots. So yes, you would have to go all the way to this line on the test because it's going to have 2 boxes. One for you to factor completely and one for you to find the roots. So now I would find my roots and I would have 1/2. I would have a negative 1/2 and then I would have 2x squared plus 3 equals 0. So I would minus the 3 and divide by 2 and then I would square root. So I would have plus or minus the square root of 3 halves. Negative 3 halves, right? I would not accept that because number 1, you can't have a negative. So this would be I root 3. And number 2, you can't have a root on the bottom. So if I rewrite it by splitting it up, then I would have the root 2 times the root 2 would become 2 on the bottom. And then it would be plus or minus I root 6. So that would be your other 2 roots that you did all the way through to get that work. So I would have answer 1, answer 2, and answer 3 and 4. So, and again, on the test, you'll have a box to put all of this in so I don't have to search and find it because there is a lot of work, which is going to mean it's going to be a whole lot less questions because I know each question takes a lot of work. Okay, so taking a look at this one, if I make my chart on this, I have factors of a negative 8 that add up to 7. So I believe that's going to be 8 and a negative 1. So I would say x cubed plus 8, and I would say x cubed minus 1. These are both perfect squares. Cubes, I totally meant cubes. So this would be x plus 2, and then x squared minus 2x plus 4. And then this would be x minus 1, and then x squared plus 1x plus 1. These two are definitely factorable. So one of my roots would be a -2 and one of my roots would be 1. Okay, and this is a lot like the one that we did earlier. Okay, and once you've seen them, that is kind of the nice thing about this. It's just kind of the same process. So if I'm going to go ahead and complete the square on this one, just to remind you how to do that. You move the 4. I'm going to half it and square it. So I get x minus 1 squared equals a -3. So I square root both sides, and I get x minus 1 equals plus or minus I root 3, and then I would move the 1 over. And I want you guys to think about something. This answer looks really familiar. I think we've done it before. If you think about it, I told you guys there's only 6 perfect cubes. So you're going to run into the same questions over and over again. So it should seem familiar what I just did. I believe we did this one yesterday. Okay, now I need to find this guy. And I'm going to do it by the quadratic formula. So -b plus or minus the square root of b squared minus 4 times a times c all over 2a. So -1 plus or minus, that would be 1 minus 4. So that's a -3. So my answer would be a -1 plus or minus I root 3 over 2. And so that is the other answer. So if I look at these, I've got one answer here, one answer here. I have 2 there and 2 here, and it is a degree 6. So that gives me 6 answers, which is what I'm supposed to have. So the rest of the time right now today is to work on homework.